And so we started off Friday, I put that word up on the board, tonicity, right? And that describes the ability that a solution has on a cell, whether the cell is going to gain water, lose water, or it's not going to change at all, right? So there's three things that can actually happen to a cell. So if you drop a cell in one solution, it might lose water. You drop a cell in another type, it's going to gain water. You drop it in the last one, nothing's going to happen to the cell. It's going to stay the same. So today I want to go over those three types. Those three types of solutions that you're going to need to know for your test. Now, you see the big word, isotonic solution? Most everybody, you've seen that one Friday. Most of you had that on there and you were writing it. Just like any other thing, remember, split it in half. Okay, now you know what tonic means. It just means whatever that definition is. But iso means equal. Okay, iso means equal. Iso means equal. You probably should write that down somewhere. Iso means equal. Okay. Well, now that we know that iso means equal, if you look, and let me know if I go too fast, an isotonic solution, so we take a blood cell, we drop it in a solution that's isotonic. See the arrows? Perfect. There's how many arrows going in? How many arrows going out? Is that cell going to change its size? No, because the water inside it is equal to the amount of water outside it. You got to remember, diffusion, water likes to move. It likes to go where there's a lot of it to where there's not a lot of it, and it just does it automatically. It's just one of those natural laws. It happens. So if you, like right now, if you're like me, I'm hydrated, I'm not really thirsty, my red blood cells are normal shape because my blood is an isotonic solution, so the water going in is equal to the water going out. Easy. Easy. Now, the next one, just as easy. Okay. Hypotonic solution. Have you heard of a hypodermic needle? That means it goes under the skin. So hypo means under. And you know what tonic means? So just go read it, definition. So this means under. And here's a cool way to think about it. Again, just look at the picture. You have three arrows going in. So that represents the water going into the cell. And look, you only have one going out. And so you know that probably this cell was dropped into a solution where there's way more water out here than there is in here. And so it rushes in and the cell gets bigger. Now, I wouldn't recommend you doing this, but if you take a saltwater fish and you drop it into a freshwater tank, all of a sudden, all of its gills are going to be surrounded by this super pure water. And so the water is going to rush into the gills. The gill cells are going to swell, and about 30 seconds in, you're going to see the fish start kill over as its gill cells start to pop. They're going to break open, and it's going to die. It can't get rid of the water fast enough. And the same thing with our blood cells. We used to do a lab where we placed our blood cells in distilled water, and you could actually watch as they got bigger and bigger and bigger. If you put hydrogen peroxide in there, then they can't take it because hydrogen peroxide really rushes in and they pop. That's how it kills bacteria. So that bubbling you see is the bacteria just like causing a reaction. They break open and they release chemicals that show you this bubbling. Even they can't take it. Okay? But that's a hypotonic. So the water concentration is way more higher out here than it is here. Okay, questions on that? Easy. Oh. Shut that door. Okay. Thank you, man. You ever notice when you're a little kid and you stayed in the bathtub too long or a swimming pool too long and you pulled your hands out, you looked at your hands? What happened to them? They got wrinkly. Well, you know what causes that, right? The water is more pure in the pool than it is in your hand. And so your cells of your skin absorb it, and the skin actually increases in size, and so it has to wrinkle. And you're like, wow, okay, well, I look like an old person. So that's why it happens. Okay. Next one. Hypertonic. Hypertonic. Back in the 70s and 80s, they called people who had a lot of energy, they called them hyperactive. Do they still use that term? Ms. Hagee, have you heard that term lately?
Depends on what generation is speaking.
My generation would say
Yeah.
hyperactive. I'm not going to say his name, but it's a true story. In 6th grade, a guy named Joe, and I'll leave it at that in case this ever gets out to him, was really hyperactive. He was a teacher's nightmare. Wasn't a bad guy, he was just hyperactive, had a lot of energy. About 3 weeks into the school, he brought 2 chickens to school in his duffel bag. I always tell it because he was hyperactive. Dude could not sit still. He was always like this. Just gotta move, gotta move, gotta move. Principal walked by the locker, here's the chickens clucking. Opens up the locker, the chickens fly out, 2 of them. Next thing you know, you hear he was in my English class at the time. That's one of those moments that you remember all your life. We could hear chickens in the hallway. Mr. Joe, I'm going to say his last name. Come on out. It took him 2 hours to catch the chickens. He was running around the school. Every so often you'd see him run by our classroom. He was so hyperactive. After that, though, he wasn't. But now, when you're talking a hypertonic solution, think about it. If you drop a cell in salt water, because that's a hypertonic solution, look what's going to happen to it. You can tell by the arrows, there's so much water coming in, but more water going out because the water concentration here is greater than out here, and so by nature it just wants to leave. You know, think about when you pulled the potato out of the salt water. Most people are like, wow, this is cool, it feels like plastic. And the potato was real gooey. That's because all the water was pulled out, drawn out. It was dehydrated, bless you, out of that potato. But yet the other potato that you had in pure water, that thing was like rock hard, and you just barely bend it and it would break. But this, it makes it really gooey. And so on this right here, that's what would happen to your white blood cells in every blood cell. Now, true story. When I first started teaching, people still, even then, went to Florida for spring break. 6 or 7 college students rented a boat, loaded it up with alcohol, got out, the boat quit, they were 2 miles offshore. If you know anything about Florida and the Atlantic, there's a big strong current and it starts taking them out. Well, they don't have a radio, and the only thing they got to drink is alcohol. They start drinking the alcohol. People that were smart stopped drinking because alcohol dehydrates you. 2 days later, they were found, there were 2 alive. The other 4 or 6, I can't remember, got so dehydrated from drinking the alcohol and then stopped drinking the alcohol and then stuck their face in the ocean and started drinking the water. And so think about the salt you're adding to your system. So not only do you have alcohol in it, but now you got salt. And right, remember salt, look what it did to the potato. Their brain cells shrunk down. The people that survived said they were seeing things, and they saw doorways and walked off the edge of the boat. They saw the ships and they jumped in to try to swim. That's just a side effect of being dehydrated. Okay? And so this is what happened to their brain cells. Their blood became so toxic, less water in it, that it pulled all the water out of their other cells. Okay? True story. I wish I could find the newspaper clipping and let you guys read it. It was quite terrible. But 2 people actually survived it that I remember. So you have isotonic, hypotonic, hypertonic. You need to know. Yeah. Questions?